So now we'll move on to trigonometric equations, and basically you may be given an expression. The first thing you need to do before being able to solve it is make sure it's only in terms of one trig function, and it's important that what's inside the bracket, so like this, they can't be different, otherwise you're not going to get very good. You're not going to get anywhere. So it needs to be the same trig function in terms of the same trig function. It's the first thing you need to do. The second thing you'd need is just, well, it depends. So for now we'll start when you just have something like, it's in terms of sin x, cos x, or tan x. And the stress is having simply just x in the bracket. And you could pretty much end up with two types. You could end up with a type of linear or a type of quadratic. And remember, it could look something like this. And you would just multiply that out. Multiply the denominator out. And there you go, like this. And that would lead me to the next thing that is important for you to realise. You need to know how if the domain can be an issue. Because this could be very simple. I could have done the domain of the inverse function. You just put the one on the calculator. You get on the calculator because you only get one answer. But if I was a bit more typical of an exam question, it might be a bit different. So the typical one would be 0 to 2 pi, which is the same as 0 to 360 degrees, by the way. Actually, I'll do 360 degrees. And then if I do tan inverse of that, I get 18.4 degrees. But if we pop up our graph, you see on your calculator, it only gives you like the principal value. We would notice that our 360 is here, and we're trying to get it to equal a third. We get not only the 18 degrees one, but something up here. And that's equal to, because the period of a tan graph is 180, do 18.4 plus 180. So then x is equal to 18.4 or 198.4 degrees. And for angles and degrees, we round to one decimal place. So you get something like that. Or you could get a quadratic type thing, and something like this. And remember, it could look like fractions, but remember, just multiply out the denominator. And then you would, perhaps you would do, to make it easier, you do a u sub. Then you'd factorise it, because then you'd do the AC equals minus 6, and you'd figure it out. I'm not going to do all the lines of working, just to save some time here. I know it's going to be like this. And then so this will just end up as u plus 2, 3u minus 1. And then we'd see, okay, u is either minus 2, which is sine squared x equals minus 2. We'd reject because we don't do complex numbers in AS. And then we'd see sine squared x equals positive a third. And sine x is root of 1/3, which is root 3 over 3. Well, it doesn't really matter. And then we do x equals sine inverse of root 1 over 3. And if you were to put that into your calculator, you get about 35.3 degrees. But you need to remember, again, say we're doing, I'll stick with the same usual domain of 0 to 360 degrees. We're wanting it to be a root of 1/3. So we're going somewhere like this. And we're getting 2 points of intersection again here. Now what is that? Well, here, notice that this gap here will be the same as this gap here. So what we would do is just do 180 minus 35.3. And that would give us 144.7 degrees. And I should also note that if you were given a negative, it was negative and you still needed the domain in 0 to 360, because you get something here. The two solutions will be up here. So here, because that's your this is your x-axis. This distance is the distance between 0 and the distance between 180 is still the same. So you'd still do 180 minus x for the first one, but then you'd have to do 360 plus x for the other one, because again, same distance here. So you just do 360 plus that negative value to get your second solution. And then again, that may not be the domain you want. It may want the negatives, in which case you just you do the same bit for the negative side. And if anything, I personally use the graph to do find the other solutions. You can also use the unit circle, perhaps with different domains. Unit circle may be helpful. For example, if I show you this one, if you remember the video on how we define those angles, by doing this sine inverse, we get the basic angle. So we either have something up here or a negative one down here, and that would tell us angle and direction. And then we can factor in by using the domain, we can figure out the quadrant that will end up in. While using our sine inverse, we can figure out what quadrant it will end up in, and then we can use the domain and write it on the unit circle. Say it wanted -2, -pi, and then it became -pi over 2, then 0, then pi over 2, and then pi. We could do this one. So we're doing the same thing, but we're trying to get it in the domain -pi to pi. So we're saying the basic angle happens to be 35.3 degrees. So we know it makes a basic angle in the anti-clockwise direction of 35.3 degrees. Oh, why am I'm being rather confusing with this pi stuff. We'll do 180, -180, -90, 90, and 180. And we know it goes up 35 degrees this way. And so that means we say, okay, minus 180, and we add the 35.3 to get that one. But remember, there's going to be another solution over here, because that sign's going to be the same. So what we'd do is I would do 0 minus 35.3 to get that other answer. So if you've got a funky domain, maybe use a unit circle, that might help. But in general, I tend to use the graph, but there are uses for the unit circle as well. And I'd just say if it ended up being negative 35.3, here's what I would do. That tells us we got a clockwise rotation of 35.3 degrees. And we get this thing down here. Then you get the other solution over here, but we don't worry about that for now. Then here, because you did an anti-clockwise one, we can't go further below negative 180, so we have to just go less than 180. So 180 minus 35.3. And then for this one, we would go, you could do 0 plus 35.3 probably. And that would give you your answers. Then sometimes you might get that's the simple part when x is in, it's just x in the bracket. It can get a bit harder when maybe you don't have just x in the bracket. So for example, 3 cos 2x minus 4 equals 2. And we're doing the range 0, x and 2 pi. What I would do is I'd say let u equal 2x minus 4, and I'd write this as this. And I would get x in terms of u, because that's u plus 4 over 2, and then I'd put this into this domain so I can figure out what domain I need to be using. Like that. And now I would solve normally. And then u is equal to cos inverse of 2 over 3. Which actually is almost 1. It's like 0.9999. And that's equal to 2x minus 4. So 2x equals 4.99999, and x equals, we'll round this to 5 over 2. But we need to make sure it's we get all the solutions in that range. So, pop up a graph maybe. This is 0, this is negative pi over 2. Um, 4 is going to be roughly here, because this is pi here, and then that's going to be 3 pi over negative 3, that's negative pi down here, and that's negative 3 pi over 2. So we know 4 is going to be roughly in here, so we don't need to worry about that too much, because remember we're going for when this whole thing is equal to 2/3, which is positive. And we're going to all the way to 4 pi minus 4, and so we will have to keep going, and in fact I'm going to have to do this a bit do a bit more. And then 4 pi minus 4 is just a bit more than pi, so that's 3 pi, so that's 4 pi minus 4. And we're trying to find all the ones where it equals a 2/3, right? So we'll cut it at 4 points. This one will be about 5/2. And we'll notice that the other one will be negative 5/2. Then we'll do 2 pi minus 5/2, because remember, same thing with sine, these gaps are the same. And then this one's just going to be 2 pi plus 5/2. And you can rewrite those as decimals or whatever. I'm just showing you the general process at the moment. So that's what I would do, a U sub, and then I'd rearrange the domain just to be careful about that. And as I said, you could have a domain like this, or it even could be in degrees. Something like this, it could be, there's a whole lot of different possibilities. And also, the final thing I probably will say about this is look out for self-quadratics, like cosine to the 4th plus cosine squared and whatever, But pretty much but the most important thing I would say is probably look out for the domain and get all the solutions. Don't forget to plus minus square roots if you have to, especially when it's like something like sine 4th theta plus sine squared theta plus 9. Don't forget to plus minus the square root. I don't know if this has a positive discriminant or not, doesn't matter, but you often need to not forget to do the square root there. Oh, and another final thing you may have to do is determining the number of solutions in an interval. So like if it might tell you equation of a line, you need to tell, it says, okay, between this and this of a certain trigonometric graph and this line, how many times does it cross? And for example, it said the interval 0 and 2 pi, we have two intersections. And so the way to solve this would just be to do a sketch and figure it out. Don't miscount the intersections like I sometimes do, though. But that's essentially it, I would say. Oh, and say we were solving for cosine, doing this run over here, you'd then do a vertical line to get this one for the cosine. That's how you use the unit circle. And then for tan, I recommend you just use the graph and not the unit circle at all.